All right, guys, this is Mrs. Lyons, and I am going to make a video that explains single replacement reactions. Okay, so these are a little bit different than things that we have been doing, synthesis and decomposition, because in those cases we're either putting something together or we're breaking something apart. In a single replacement reaction, what happens is one element takes another element's place. Okay, so if we look at this example, we have zinc plus silver nitrate. Okay, the first thing that you want to do is identify the element. Okay, so the element is always going to be the thing that is just the single type of atom. Okay, then you're going to compare to a similar element in the compound. And I'm going to change that, not to a similar element, a similar type of atom. What I mean is, if the element is a metal, we want to compare it to the other metal. So if I look at this compound, silver is the other metal. Okay, so it turns out single replacement reactions do not always happen. Sometimes they don't happen and we have to write no reaction. So we have to figure out how to go about that. And to do this, you're going to need this thing called the activity series, and it's on the back of your periodic table. Okay, and what this is a list of metals. Okay, and the metals at the very top are very, very reactive. The metals at the bottom are less reactive. Okay, what happens is, in a single replacement reaction, the more reactive element is the one that's going to end up in the compound and not by itself. Okay, so what we have to do is we have to compare the elements. Okay, so for example, in this reaction we have silver and zinc. So I'm going to find, so here's silver and zinc is all the way up here. So zinc is higher up than silver. So just to help me know that, I'm going to put a little star by zinc, saying that it's more reactive. So what's going to happen is zinc is going to take silver's place. Okay, and what I mean by that is zinc is going to come in here and I'm going to have zinc nitrate. And then silver is going to get kicked out and be by itself. Okay, so it's nice to write the words first, and then you go in and you can change it to the elements and compound symbols, the equation. So here I would have zinc. Remember, zinc is a metal. I guess it doesn't matter that it's a metal. To figure out the states of matter of the individual elements, most of them are going to be solids. If they have the black background, they're going to be gases. And if they're underlined, they're going to be liquids. Okay, so zinc is a solid. In single replacement reactions, okay, all compounds, and I'm going to write this over here, all compounds are aqueous. Okay, so in this reaction, I have solid zinc metal plus aqueous silver nitrate, AgNO3. It's going to produce solid silver and zinc nitrate, also aqueous. Okay, so let's just get down to doing one of these. Okay, we'll do a couple together. So sodium plus aluminum sulfate. So I'm going to look. Sodium is a metal. It's on the very left side of the periodic table. So I'm going to compare it to the other metal, which in this case is aluminum. So I'm going to go to my activity series, and I need to find aluminum and sodium. So where's sodium? Sodium is up here. Aluminum is 2 below it. Okay, so sodium is the most reactive. What that means is sodium is going to end up as part of the compound. So sodium is going to kick aluminum out. So I'm going to go over here and I'm going to say I have aluminum. I can't spell. And I have sodium sulfate. Now that we have our word formula, all we have to do is translate it into a chemical formula. Okay, so sodium is Na. It is a solid. Okay, we react that with aluminum sulfate. Remember, when we have a compound, we have to look at charges. Okay, so remember, group 1 is +1, group 2 is +2, group 3 is +3. Group 4 we don't see very often. It would be plus or minus 4. -3, -2, -1. Okay, so if I'm comparing sodium has a +1 charge. So I'm going to write that right here. Sodium has a +1 charge. And then sulfate, remember sulfate, we have to look back here. Sulfate is SO4 with a -2 charge. So -2. All right, so if I crisscross my charges, I jumped the gun. I got sodium sulfate. I didn't do aluminum sulfate. So let's do that first. Sorry, guys. So aluminum, in aluminum sulfate, aluminum is +3. Sulfate, we already looked it up, is -2. So if I crisscross charges here, I get Al2SO4 3. That's going to be AQ, or aqueous. Okay. Next we have aluminum. So aluminum metal, Al, solid, plus sodium sulfate, so Na2SO4, and that's going to be aqueous. Okay. So let's look at another example. We'll do a couple of examples. Okay. All right, so let's give myself some writing room. So we're going to do aluminum plus lead nitrate. Okay. So the first thing, and I'm going to rewrite this down here just so that aluminum plus, and this should say lead 2 nitrate. Remember that lead is one of those transition elements, and if you don't have the Roman numeral, you can't know the charge. Okay, so we've got to look at our activity series, and aluminum is the element by itself. It's a metal. Lead is another metal. So let's see. Here's aluminum, and lead is all the way down here. So aluminum is above lead. So I'm going to put a little star by aluminum. Aluminum is more reactive. So what's going to happen is aluminum is going to kick out lead. So now we don't really need to know the charge of lead because it's just an element. And then aluminum is going to take lead's place. So we're going to get aluminum nitrate. Okay, so now we just need to write the chemical equation. Okay, so aluminum is Al, it's a metal, so it's a solid, plus lead 2 nitrate. So lead, the Roman numeral 2 tells us it's got a plus 2 charge. Nitrate, if we look at the back of our periodic table, we find, where's nitrate? Here we go. Nitrate is NO3 minus 1. So nitrate is minus 1. So we end up with PbNO3 2, because we crisscross charges. That single replacement, the compound's always going to be aqueous. We're going to react that. We're going to get lead, so just lead metal, which is Pb, solid, plus aluminum nitrate. So we already know nitrate's charge is minus 1. Aluminum is plus 3. So if we crisscross, we get Al. Remember, I can write the 1, I don't need to. And then we get the polyatomic ion nitrate with a 3 after it. And that's going to be aqueous. Okay. So then, looking back at our worksheet, we're going to do, let's see, we're going to do 2 more. All right. So we're going to do number 3. Okay, so number 3 says we have, and there's something different about number 3. Number 3 says we have barium, iodide, plus chlorine. Okay, so now you're going to see something different. We always want to start by looking at the element. Well, notice that these are all metals, and chlorine is not in this list. We have this little list over here, and these are the halogens, okay, group 17 elements. These are nonmetals, and only a nonmetal can replace another nonmetal. So this list is all by itself. It doesn't go with the other list. So what we see is fluorine is most reactive, astatine is least reactive. So if you look at your equation, you have chlorine and you have iodine. All right, so chlorine is here, iodine is 2 lower. So chlorine is the most reactive. So it is going to take iodide's place. Okay, so it's going to kick iodide out, which is going to be iodine, plus barium chloride. Okay, so barium, I'm just going to go through this relatively quick because this is repetitious, but barium's plus 2, iodide is minus 1, so we end up with BaI2 plus chlorine. Chlorine, we didn't talk about this on our other examples. Chlorine is a diatomic element. Remember, it's one of the Hoberfinkel 7, so it gets a 2. So we said reactants, the compound is aqueous. Chlorine is a gas, if you look at the periodic table. And then it breaks apart to form iodine. So I is also one of the 7, the Hoberfinkel 7, a diatomic element. Iodine is a solid. And then we end up with barium chloride. Barium's plus 2, chlorine is minus 1. So BaCl2, aqueous. All right, so one more reaction. Let's see. I'm going to make one up here because there's something that we didn't see in these examples, and we didn't see a reaction that doesn't happen, okay? So I am going to, let's say we have lithium chloride. Oh, let me write this in words first. Lithium chloride, and let's go with zinc. Okay, so the first thing you do, you look at the element. In this case, the element is zinc. It's a metal. So if it is going to replace, it would replace lithium. So I have to compare lithium and zinc on my list. Well, lithium is all the way at the top. So lithium is above everything. Lithium is always going to be in a compound. So in this case, lithium, check it, is already in the compound. So it doesn't have to kick zinc out. It's already there. Okay. So what happens is this you write no reaction. And that is as far as you have to go with that. Okay, so that's the important kind of little tricky thing about single replacement is you do have to check to see if the reaction happens first or not. All right, so that is single replacement reactions. I hope that helped at least a little bit, and I will see you in class. Have a wonderful